Hi. Now we're going to be into Module 3, Protocols and Models. So based on the feedback I got last week, I will try to break this down into 3 or 4 different videos. I think the first one I'll start with just the rules. The next one will be protocols and protocol suites. I may do standards organizations and reference models together, and then maybe the data encapsulation and data access together. We'll see. But there are 7 sections in this chapter, so we'll see what makes sense. So the question is, why am I taking this module? Why am I doing module 3? I mean, what is this? Well, basically, it covers, you saw a little bit last time on the basic components, switches and routers and a little bit of media that connect it, and you've identified some things in Packet Tracer to help you identify them. Well, the question is, those devices have to communicate with each other. Same as when the two of us communicate, there are certain rules. Some of it's implicit, some of it's explicit, as far as what rules are we going to communicate by. What language, is it going to be verbal, written, email, text? So with humans, it's fairly easy to make that just adjustment, and sometimes we can interpret things that the sender didn't expect. Well, basically protocols are the set of rules that are agreed upon by all the computer industry, network industry to say how devices are going to be talking to each other. So we'll look at the rules, which is describe the types of rules, protocols, why they're necessary, a list of protocol suites. There are groups of rules that some of it is official standard, some of it is a de facto standard. And we'll talk about those. We'll talk about the standard organizations, who controls all of these rules. And then we'll look at different reference models as far as how to explain what's going on. It's one thing to have electronic bits flowing through wires and stuff. The question is, how do you tell somebody else? And then we'll talk about how data's got to be, information's got to be wrapped around the data you send to get from point to point, whether it's going over a switch or a router or wireless or Ethernet cable. From destination to destination, you don't know what information is going to be on this, where they're going to go, because you saw diagrams how complex what that intermediary devices can be. A packet doesn't know which device it's going to hit, and the protocols tell me I've got to provide some information as to what kind of data is, and I've got to send it to the next destination so they know what to do with it. So we'll talk about a little bit of data encapsulation, data access. I won't force you to do the class activity since you probably won't be together in class. So let's look at the rules. Now, I'm not going to play the videos. I really highly recommend you play these videos. Don't just watch mine, because there's a lot of good information that may appear on a text. And this one just talks about protocol devices and their place in networks. Now, communication fundamentals, networks, we saw that they're different shapes and sizes, whether they're just for the home, whether they're for a small business or a country, a city, and they can be very simple and very complex. Because we send messages all the time. Now, just remember, there are always going to be senders and receivers, or source and destination. In Cisco and the network industry, usually you'll see source and destination used more than sender and receiver. Basically, your source is who's originating that device's destination is who's going to receive it and interpret it. The channel basically is the media in which it travels through. Now, communication protocols, like I said, this analogy is we use rules all the time to govern how we talk to each other. We think of a message, we verbalize it, it goes across the airways, you hear it, your ears process it, but it's still the same concept of what a computer does. You think of a concept, you type it in, it forms that message. It has to then get to the media, so it has to be formatted into something that'll go across the physical media, whether it's over the airways on your phone, you're sending a text, or if it's over an Ethernet cable on your office computer or your home computer. Transmits over that, it's got to be received, and of course the messages. So you basically got to make sure you review, you just got to agree what those rules are prior to everything going on. Now, with this, most of the time you have to set up some kind of rule establishment. You got to say, before we can communicate, we have to agree on certain things. Now, humans, we govern rules very easy. I mean, even if you look at this picture here, the message is typed and garbled and stuff, but our brain can interpret this and put it into a way that we understand it. So there's things that humanly we can do that computers just can't do. Protocols must identify who the sender and receiver are, what the common language is, what kind of speed and timing is it going to be delivered, and how do I confirm the message was received and acknowledge that it was received. There are some protocols that say, hey, I don't care, I'm sending it, and I'll let you worry about it if you didn't understand it. And there's some protocols that says, hey, I'm not going to the next step until I know you got that data and you've accepted it and it's nothing happened to it. Now, some of the protocols requirements that are necessary, there are certain things that need to take place. In the next few sections here, we're going to talk about how a message is encoded, or how is it changed, how is it formatted, and encapsulation. Encapsulation is just a way of wrapping things around the message you want. And based on what devices you're talking to and where you're going from, you'll encapsulate, you'll put more different information around it. You have to agree on what the size is, how fast it's going to arrive, and what kind of options for delivery are there. So let's look at encoding a little bit. Encoding basically is a process of converting information into an accepted form for transmission. And then decoding is just the opposite of that process. You can play the little video as how that goes through that. You got an analogy here you can go through. You can play the network. So it really boils down to, do you want to see what you're talking to, what we talk about in human nature, or on a network side, what takes place when a message is typed in, it's encoded, transmitted, and go on. I highly recommend, again, playing that video. Here you got encapsulation, formatting, encapsulation. This is when a message is sent from source to destination, a specific form is required. Message format depends on the type of message and the type of media that it's going to go out, the type of channel it's going to go out. The analogy here is one we're very used to is a letter. So what do you have to do? I have to have an address. I have to have a return address. So I have to have a physical address, and this physical address, 1400 Main Street is a physical address. It doesn't change. Recipient can change. People can move in, people move out. So I've got physical addresses, I've got logical addresses, I've got destination address, source and information, all of this stuff. And of course, what goes in the letter? The content of your message. So the envelope, all this addressing on the outside is encapsulating information to allow this letter, the information inside, to be sent. Of course, you can go ahead and play the network side and say, what happens? Well, basically there's two formats that we use today. There's an IPv4 and an IPv6, Internet Protocol, IP. version 4 and a version 6. And it has a different format, and I got a certain source destination, address. So let me just bring that, oops, let me go back down, that's too big. So this protocol has defined certain rules to put that address on. Now, message size, again, our analogy is I've got to agree as to how big a packet of information can be. In face-to-face conversation, we can talk all day long, right? But in a network, I've got to decide when a long message has got to be sent, how long can I wait? It's one thing if I'm just a single connectivity and I've got nothing else to interfere with. Nobody else want to bother. I've got a transmitter, receiver, and nothing else happens. But if I've got a very complex network, I can't dominate the whole network while I'm sending my one large message. I have to break it up into smaller pieces, so I have to negotiate the size of the packet that's being sent. Message timing, basically it says I need to worry about how fast am I going to talk, how am I going to control the conversation, how long am I going to wait, like how many times you've been on the phone and you kind of hear silence on the other side and you say, well, how long am I going to wait before I figure the call got dropped? So things like that. And access method just says it determines who can send a message. And you got to make sure that if people are talking and they're miscommunicating, I got to know what to play with it. Now, of course, there are different ways of delivering messages. Conversations mean we can have what they call a unicast. It can be one person to one person. It can be multicast. It can be me to selected individuals, or it can be a broadcast. It can go to an entire group. I'm hoping, even though this may, as you're listening to it, it may seem like a unicast conversation, but my intent is I'm broadcasting this message across the whole class. So in a network, the same thing happens. In a unicast network, I'm going to send it to one destination. Multicast, I got the same packet, but I'm going to go to not everything, but just selected destinations. And at broadcast, I'm going to go to everybody. Now, that multicast address is used as a default by a switch. So we got to be careful, as if that's not your intent, there's things as we lay out and design your switch that makes sense, that helps. Let's see. Here they just give you a little note on drawings. Just pay attention to where the head of the arrow is, tell you which you might be talking to, one device, 3 devices, or everybody. So hopefully that gives you a rough idea on rules, and then I'll go to protocols and protocol suites. Have a nice day. Bye-bye.